So welcome back, and we're carrying straight on with our compound and double angle formulas in trigonometry. Let's dive straight back in. So first up now, we are told that sine of 12 is m, and then the very first thing we've got to do is find the tan of 12. So what we're going to do is we're going to draw our little diagram here, and we've got a 12-degree angle over here somewhere, and then we've got, remember that sine is our y value over r, so m over 1. Okay. Obviously, this side, if we use Pythagoras, we get 1 minus m squared. It's 1 squared minus m squared, but it's 1 minus m squared. So tan of 12 is just going to be our y value over our x value. It's going to be m over root 1 minus m squared. Okay. The next one is sine x cos 6. Now sine x cos 6 looks a lot like our double angle formula for sine. Right, but it would be nice if it had a 2 here. So if it was 2 sine x cos 6, we can't change the question. We can't make it 2 sine x cos 6, but what we can do is write it like that. Okay, 2 sine x cos 6 is just sine of 2 lots of 6. So in fact, our answer here is half sine 2 lots of 6. 2 lots of 6 is obviously 12, so it's half sine 12. It's a half m. Okay, 2 sine squared 6 minus 1, well that's very close to our formula for cos of 2 theta, but it's the negative thereof. So in other words, we're going to write it like this: 1 minus 2 sine squared 6. Right, so in fact it's minus cos of 12 degrees. And we can get that off our diagram, because cos of 12 is just going to be root 1 minus m squared over 1. Okay, right, then cos squared 6 minus sine squared 6, well that's just our straight double angle formula for cos. That's cos 2 lots of 6, or cos of 12, and that is going to be exactly the same as the previous question. Well, not exactly the same, it's going to be the square root of 1 minus m squared, no negative this time. Okay, and then the last one, cos 58 cos 20 minus sine 58 sine 20. Well, that is our compound angle formula for cos, and this is in fact cos of 58. Remember, cos changes the sign, so this is cos of 58 plus 20. Now 58 plus 20 is cos of 78. Where are we at 78 degrees? We're in quadrant 1, and we're 12 degrees away from the vertical axis. This is the same as cos of 90 degrees minus 12 degrees, which is just sine of 12 degrees, which is just m. Okay, we are hoping that you're starting to realize that key to being good at this stuff is learning all these identities. Right, let's try another one. We're going to ask you to pause the video, try it yourselves, and then we'll go over it shortly. Okay, so if we look at this, this is very similar to our double angle formula for for sine. So it's missing a 2. So what we actually know is that 2 sine 17 cos 17 is actually 2k. So therefore we know that sine, because this is sine of 2 lots of 17, we know that sine of 34 is 2k. So now we can proceed as normal, right? So sine of 34 is just going to be 2k. Sine of 56, well, that is 34 degrees away from a vertical axis in quadrant 1. So sine of 56 is the cos of 34. And that we can easily get, because if we draw a little sketch, let's draw a little sketch. We've got our 34 degree angle over here. And remember that sine is y over r. So this is actually going to be the square root of 1 minus 2k all squared, or 4k squared. So cos of 34 is actually going to be the square root of 1 minus 4k squared. Okay, cos of 68. Well, let's try and think about where 68 is. 68 is actually twice 34. So that's going to be cos of 2 lots of 34. Now, we know an expression for sine of 34. So let's go with the 1 minus 2 sine squared 34 flavor. Remember, there are 3 different flavors for cos of 2 theta. So in fact, this is going to be 1 minus. Now remember, sine of 34 is 2k. So sine squared of 34 is going to be 4k squared. So it's going to be 1 minus 8k squared. Right, let's just clarify that. Why it's 8? Because we've got 2k all squared will give us 4k squared, but then we need to multiply by that 2. Tan of 56, well, tan of 56 is going to be the same as sine of 56 over the cos of 56. But remember, we already established that the sine of 56 is actually the cos of 34. So in fact, tan of 56 is going to be the cos of 34 over the sine of 34. Right, it's actually going to be, cos is going to be root 1 minus 4k squared. And sine is just going to be 2k. Right, so that is what tan of 56 looks like. Sine of 274, right? Well, at 274, let's try and think about where we are. We're 4 degrees away from a vertical axis. That's not necessarily all that helpful, but we are 86 degrees away from. Okay, let's see what we can do here. Sure, so this is a little tricky, but in fact we can do it, because we can use the 34 and we can use a special angle. So sine of 240 plus 34. Now sine of 240 plus 34 is going to be sine 240 cos 34 plus cos of 240 sine 34. Right, sine 34 we know is 2k. Cos of 240 is in quadrant 3 by 60 degrees. It's the same as negative cos 60. Sine of 240 is the same as negative sine 60. And remember that cos of 34 we've already worked out. It's the square root of 1 minus 4k squared. Okay, now sine of 60 is root 3 over 2. So our final answer here is going to be negative root 3 over 2 times root 1 minus 4k squared. And cos of 60 is a half, so it's going to be negative a half times 2k. Okay, which obviously simplifies, but let's leave that one right there. Okay, next up, and what we're going to be busy with from now, is proving identities. Now we've proved some already, right? And we've already done some, but now we've got a whole lot more identities to deal with. We've got all these identities, all of them must be learned. We're going to do a couple, and then we're going to ask you to try a couple and on your own. Remember, the first thing, most important thing, is we just work with one side at a time. So let's work with the left hand side here. All right, and we've got to try something. Now, an important idea is that on the right hand side there's only one term. On the left hand side there are 2 terms. So in fact, what we're going to do first, we're going to try and add these 2 fractions. Right, now the common denominator that we'll use is sine x cos x. So there's the first fraction. Here's the second fraction. Right, and you might remember in grade 8 and 9 and 10, we emphasized the importance of being able to add fractions without a calculator, right? Because we really need to understand what we're doing here. What must we do to sine x to make it into a sine x cos x? We're going to multiply by cos x. So what we're going to get here, we're going to get sine 3x cos x. And here we're going to multiply by sine x, so we're going to get cos 3x sine x. Now they have the same denominators. So just to emphasize what we've done here, there's that fraction there, all right? This here is this fraction over here, okay? But we've got them with the same denominators. Now we're going to add those two fractions, and our denominator is going to be obviously going to be sine x cos x. And even as I write down sine x cos x, I'm thinking, I know some stuff about sine x cos x. Okay, it looks like something, but let's just wait and see what happens on the top here. On the top, we get sine 3x cos x plus cos 3x sine x. Now listen carefully to that. Sine 3x cos x plus cos 3x sine x. And this is where it's so important to know our identities, because that is the right-hand side of an identity. That is sine of 3x plus x. I'll show you where it is. There it is over there. So this here is actually the sine of 3x plus x. On the bottom we've got sine x cos x. Okay, so on the top we've got sine of 4x, but sine of 4x is 2, it's sine of 2 lots of 2x. Sine of 2 lots of 2x is going to be 2 sine 2x cos 2x, right? So let's just write this down first, sine x cos x. So on the top we've got 2 sine 2x cos 2x. Okay, and on the bottom we've got sine x cos x. Now, when we expand the sine 2x on the top, we're in fact going to get 4 sine x cos x. All right, we're running out of space a bit here, but this is going to give us 4 sine x cos x. And that's the sine x cos x is going to divide on the bottom, and we're going to get 4 cos 2x, which is exactly what the right hand side is. So we write equals RHS. Okay. Right, we're hoping that you can see what we've done there. Right, we've changed the sine 2x to a 2 sine x cos x, which divides with that sine x cos x. Okay, we're going to do one more, and then we're going to stop, and we're going to ask you to try some before the next lesson. Okay, so if we look at this one, it looks quite heavy going, but on the left hand side we've got all sorts going on here. We have got, okay, let's just have a look at what we've got. We've got 2 cos theta over here, and we've got a 2 cos theta over there. So let's just have a look. Left hand side equals. We've got 2 cos theta. I'm going to leave that as it is for now. And we've got cos 2 theta. I'm also going to leave that as it is for now. Then we've got sine squared of 2 theta. So that means sine of 2 theta times by sine of 2 theta. Now when you multiply sine of 2 theta by sine of 2 theta, right, we're going to get 2 sine theta cos theta. And that's going to be squared over cos theta. So let's have a look. We're going to get 2 cos theta. Here we've got cos 2 theta. And here we've got 4 sine squared cos squared theta. But what's actually going to happen here is we're going to get 4 sine squared theta cos theta. Sine squared theta cos theta. Right, one of the cos squared thetas, or one of the cos thetas and cos squared theta will divide out with the cos theta on the bottom. Okay, now looking at what we've got here, we've got our, I'm seeing a sine squared here. I don't really want a sine squared. So if I now take this cos 2 theta and we change it out for 1 minus 2 sine squared theta, a little bit of magic's going to happen. Okay, so understand what we've done. We've taken this and we're replacing it with this. How did I know to take that one rather than one of the other ones? Because I'm going to get some negative sine squared thetas, and I don't want any sine squared thetas in the answer. Okay, so this is plus 4 sine squared theta cos theta. And then this is, when we multiply this out, we get negative 4 sine squared theta cos theta and positive 4 sine squared theta cos theta. It actually all goes out and we just get 2 cos theta left. And that is our right hand side. Okay, both of those fairly tricky ones. All right, maybe this one slightly trickier than the first one. Before the next lesson, try as many of these as you can, and we'll go over them. We'll go over them next time. We'll try and help you with some strategies as to things that you can try. Right, but before you can make a success of these, you must know your identities, and you must know them really, really well. Have a great day, guys.